Welcome to our demonstration video. In this video, I'm going to walk through the structural analysis process from modeling to pre-processing, solving, post-processing, and then looking at the results in our graphical post-processor. So for purposes of the demonstration, we're going to be modeling a rectangular plate. It has a couple of holes in it and a square cutout, and we'll be using the automatic mesher to generate all the elements in the model. So we begin by clicking on the Analytical Methods icon here on the taskbar. That brings up the program. And this is the session manager that you're seeing here. And we're going to start by modeling. We'll click Continue there. And then we're going to be running a macro within the modeler. So we're going to do New here and select FlexGen. So a macro is a series of commands that have been previously recorded that generate the model. So we will go ahead and do a File, Macro, Run, and I'm going to do it in the pause mode so that I can walk through step by step, show you what's going on. So we're going to do holes.mac, and we'll double click on that, and it begins. So the commands are down here in the left-hand corner here. So the first thing we're going to do is insert a node at the origin. That'll be node 1 there. And then we're going to copy that node, and we're going to copy it 10 times in the x direction with an increment of 1 inch. And then we will confirm creation of those 10 nodes. So what I'm doing is building a rectangular boundary that we will select at a later point here. So now we want to copy node 11 and do that 10 times with an increment of 2 inches in the y direction. And we do that, we confirm creation of those nodes, and now we want to zoom all, get them all on the screen. And so now we do the same. We copy node 21 10 times in the minus x direction, and then we continue this to complete the rectangular section here. So there's the boundary of our plate now. So yes, I want to do that. So now I want to insert a circle here, or create a circle. So I'm going to insert an axis system, a cylindrical axis system, at the center of the circle. And there's a couple of questions that need to be answered about the orientation of the axis system in space. We do that, and it appears, as you can see right there. So that's the center of the circle. We're now going to set that axis system active, and now we're going to insert a node with a radius of 2 inches, and we're going to copy that node 41 like 35 times. Go around the circle with a 10-degree increment, and those are those nodes there. That forms our first circle, and we'll confirm creation of that. Now we go back to setting the rectangular coordinate system axis here active, and now we're just going to copy the nodes that we just created for that hole, and we're going to do that once and move it down a little bit into the rest of the plate, and it appears down there now. So yes, we'll confirm creation of those 36 nodes. And then finally here I want to go ahead and put in the corners of our square cutout. So I pounded those coordinates in, and they appear right here now. And we'll set the node labels off. And now we want to insert the mesh. So we have all the outline done, the circle, the square. We want to insert the element mesh. So we're going to use plate 3s, which are triangles. And element property, we didn't create an element property yet, so we have to do that. Material property is going to be, we'll just default to 1 here. Turns out that standard material 1 is aluminum, 1100 H18 aluminum, and the thickness of the plate will be 1/10 of an inch. We'll just call it plates. for that plate property. And then we'll have a group. We have to define a group that the elements go into. That hadn't been done yet. We'll just call that rectangular plate. Now what we want to do is define the region that's going to have the mesher come in and mesh the elements in. So we do that by defining a boundary around it, and then we define holes within that boundary. So we're going to do a region boundary, and we're going to do nodes 1 through 40 form that boundary, and that's the boundary right there of the plate. Now we're going to insert a region, a hole region, and we'll do that twice here. And those nodes are 41 through 76. That's that there. That's our first hole. We do the second hole in a similar fashion, and then we do the third hole, which is the square cutout right there, and that forms our third hole. So, and now we're finished. So what we would like to do is move now to the mesher, and there's a couple of parameters to set, smoothing parameters, and then how many elements do we want it to insert here. So the default is 500. We're going to go ahead and insert 2000, and we'll just hit return. There is the mesh now that it just created. So yes, there's 2,192 elements in the mesh there that it created. Okay, so to finish this now for the structural analysis, we'd want to define all the restraints for the nodes, and then we would want to apply some loads to it. So rather than take the time to do that here, I'm going to pull up a model that made from this same mesh here that I did in an earlier time. So I'll do a file, load model, and we want to pull up the plate with holes model. I'll double click on that, and here it is. So this edge here is fixed, and all of our loads are applied over here, so we're putting the plate in tension. You can see that we can put some comments around here. So this is 21 loads at 10 pounds each, so we got 210 pounds pulling on this plate. Not a large load. The plate is 10 inches wide and 60 inches long. So, and the hole's 4 inch in diameter, 2 inch square. Okay, so we're pretty much ready to go here to the structural analysis. And in order to do that, then this is a model here. We want to do a file, save, FEM, finite element model, and it now has the .fem extension on it, so we'll save that. Yes, it's already out there, so we'll just overwrite the existing file. So now I can get out of the modeler and go back and do the structural analysis. So I'll hit exit, and yes, I want to exit. And now we're back to our modeling dialog here. I want to go back out of this, and we're going to now select structural analysis and pull that up. So now we see the structural analysis dialog, and what we want to do is come over here to pick out the model name that we're going to be running, and there it is, plate with holes.fem. So we'll select that, and you see that when I selected that, a number of the buttons down here were enabled. So it already knows that it's a static analysis, and these are, we need to run the preprocessor Flex 1, the solver Flex 2S, the static solver, and then some of the post processors here. So we could do those individually, or we could come over here and run it in a batch mode and just hit the static button here, and it will run all of these for us. So we'll do that. We'll just hit static here. Flex 1, the preprocessor, it's going to generate the stiffness matrix and all the required information for the solvers and post processors. So now that's complete. Flex Pro is a profile minimizer, and you can see that we've got a 94% improvement reduction in the bandwidth of the stiffness matrix using that. So the solver will run much faster with that. So this is about 2,400 equations. It's done already, and we go on to the Flex 3, the post processor. So Flex 3 takes the displacements found by the solver and calculate stresses in each one of the elements. So if you look down here in this area here, it's the working element. You can see it's marching through the working elements. So that will run up to 2192 and conclude. So it's writing out all the stresses in a text file. You can go look at them, and those same files will be operated on by the graphical post-processor, which we'll go to next. So, okay, so this is concluded now, and we'll pull up FlexPlot as the graphical post-processor. So here's our model, and we're going to want to look at it. We changed the view direction on it. Now I'm going to want to do a rotate screen, so I'll hit that button, and we'll do a 90-degree rotation here. Go like that, and then I'm going to want to zoom all on that, so I'll hit the zoom all button. Okay, so now we're ready to look at the displacements. I could hit displacements here, and you can see, so this is the restrained edge over here on the left side, and this is the free edge here being pulled on, so on. So the displacements, you can see the magnitude of the displacement. It's a very, very small displacement. So this is highly exaggerated. Matter of fact, we're going to change the scale factor on that. So I'll come over here and hit scale, and it's 3,000 times the size of the actual displacement. So I'm going to go down to 1,000, and I'll hit OK. And I also want to go into the solid mode, so we'll hit solid there. And now this is the overlay where the undeformed shape is in yellow, the deformed shape is in magenta here. Now, sometimes to understand displacements, it's nice to see them animated. Even though it's a static analysis, we can still animate them. So we will do that, and you can see how the thin section here in the model is being stretched and deforming the holes accordingly. So now we can stop that and go look at stresses now. So we hit the stress button here, and you can see that the highest stress is still not very high, but it is right at where you would expect it to be, right along the edge of the hole there. So we can walk through all of the stress components by hitting component plus up here, sigma 1, sigma 2, and then shear stress, tau max. We also contour the displacements. So this is the X displacement, so it's actually the lateral displacement here. And then we'll go one more. This will be the Y displacement, and that's the longitudinal displacement here. So the largest displacement was in the corner here. Okay, so we can keep doing that. We can also turn boundaries off here if it's easier to see what's going on with the element boundaries off. So let's go back to our von Mises stress here. There we are. And I want to zoom in on this area down here, so I'm going to hit zoom and pull up a little box there that I'm going to zoom in on. Okay, so I can actually now hit the node stress button, and it'll label the stress values at each one of the nodes, so you can see exactly where they are. We can take that out, and we can label element stresses, do that, take that out, so on. So we'll do a zoom all back again here. So you can do a lot with this. We can zoom in, zoom out of the model. We can rotate the model. In this case, we'd want to rotate it about Y. Hit the rotate about Y button here. Move it up and down to look at it. We've already done the zoom. We can also change the background here, depending upon what you want to do with the bitmap, the picture that you would generate from it. And then there's the bitmap button here, which just a screen capture here and send it to a bitmap file. So that about does it here then for the structural analysis demonstration. I'm going to hit the stop key here, button, and yes, I do want to exit, and we will close out now of reflex. And that would be the end of the demonstration, so thank you very much.